My name is Jim Griffioen, and I'm going to tell you a little bit about the Genie Desktop. And I am a faculty member at the University of Kentucky. Wesley Wu is a PhD student at the University of Kentucky. He's actually going to sort of run the demo and has done a lot of the development work on this. And this is a joint project with the University of Indiana. And Ezra Kissel will be talking in just a moment about the other part of the project. So Jeanne talked about GEMINI and being one of the two I&M projects. And I should say a little bit about GEMINI and the relationship of GEMINI and the Genie Desktop. The Genie Desktop is basically the graphical user interface that we've developed to relay the information that's being collected by the I&M infrastructure. So this is actually just a GUI that allows you to quickly see the traffic, the graphs, and that sort of thing. And some of you were in the tutorial yesterday and were able to use that. Since that time, the Genie Desktop has actually sort of expanded, and it allows you to do things beyond just getting at the GEMINI instrumentation and measurement data. So we'll talk a little bit about that today and some of those features. If you are going to, if you want to sort of look at details of the GEMINI and Genie Desktop, there's a tutorial online from yesterday. It has actually step-by-step instructions. So if you missed it yesterday and you'd like to go ahead and do that, feel free to go to the web pages and do that. If you just Google for Genie GEMINI tutorial, you should be able to find our tutorial there, and look for the GEC17 tutorial. All right, so I'm going to do the talking here and tell you a little bit about our Genie Desktop, which is the graphical user interface, and then Ezra will tell you a little bit more about the data collection aspects of it and how you can actually optimize it for active measurements. All right, so we can you get the screen size?
Yes, I'm trying to.
Okay, that looks like it'll work. So if you don't mind, I'm going to wander around a little bit, and I hope all of you can still hear me. Okay, so the Genie Desktop, once you've logged in, and the login procedures are all online through the tutorial that I just mentioned, once you've logged in, you're presented with this screen here, which lists all your slices that you have available to you, that you've created and that you're in some stage of working on them. The first thing you'll actually see is that it will actually go off and try to update the status and tell you what state each of your slices is in. So you can see here on the left, it actually lists your slice name, and then over here it gives your slice status and identifies what status it is in. If you want to update that, there's actually a drop-down menu here of application or of operations that you can apply to your slice. The first one being update status. So why don't you go ahead and update these just to show them what happens there. So you say update status, you say apply action, and you can do that to whichever ones have been checked here, and you'll see that it goes off and it dynamically updates the current status there to come back and tell you what the status of those slices are. The web page here is designed to allow you actually to apply operations to several slices at once. So for example, here we just updated the status of several slices. You can, in addition to that, you may say, okay, I would like to actually begin to use Genie, or to use the GEMINI and Genie Desktop. In order to do that, the Genie Desktop actually goes through two phases. The first is that we need to initialize your slice with some Genie Desktop specific software. We call that the initialization phase. And after that, if you actually want to go ahead and watch your slice as it is being monitored, we need to load monitoring and instrumentation code to that as well. And we call that the instrumentized phase. So these are two operations. There says initialize here or instrumentize. These are operations that you can select, and you can apply them to any of the slices that you have checked off here on the left-hand side. So we have a couple slices here. One that has been created, it says it has resources but has not yet been initialized. So Wesley has checked this one here. We could now go ahead and initialize it. Okay, and you could actually check several of them, and it would go off and initialize them all at the same time. So if you're, in fact, dealing with several slices, and many times when you're experimenting, you may have created several different topologies that you're experimenting with, you could, in fact, initialize them all at the same time. All right, so it goes off and does the initialization, and you can see that its status now has changed to initialized, and that means it's now ready for us to view it in the Genie Desktop. The other features here, you can actually do some other operations. We won't go through all of them. One is that you can actually renew your slice and make it longer. So if you've got several slices that you've been working on, you can see they're all about to expire. Their expiration time is listed over here on this side. If you see that they're about to expire, you can go ahead and renew all of them, and it will renew all of them at once for you. Go ahead and click on the operations here as well again. You can, if you're done with several of your slices and you want to give up the resources there, you can say delete resources, check all the slices you want to delete your resources from, and then you can quickly delete all those resources as well. We also have ways of launching you into other tools. So if you want to see your slices using FLAC, for example, you could actually click on the View It via FLAC, and it would actually pop up windows or okay, so it's actually launching two tabs over here, and each of those is creating a different FLAC tab that will show you each of those slices at the same time. So if you want to then look and compare those slices or the topologies and see them, you can do that as well. All right, so the basic idea on the front page here is you can operate on your slices, and in fact it does many of the same things that the portal does, although in this case you can actually do it on multiple slices at the same time. Another feature we've added to the Genie Desktop is the ability to create slices. So you can actually create a slice. It won't have any resources in it, but you can go ahead and create it. So you want to go ahead and create a slice. You have to assign it to a project. UK Genie is fine. And you hit create slice. It's a pretty quick operation because it's not actually giving you resources yet. But at this point, it is creating the slice. Then it tries to find out what its status is, and it should come back and say that it has no resources. Okay, at that point, then you could add resources or slivers to your slice. Okay, so this is sort of the front page. This is new from our last time, and it allows you to do a lot of the operations on slices. So I'm going to sort of focus on some of the new features and some of the more advanced features, and I should actually tell you that what we're showing you here is our development site. Most of the things I'm showing you are on our stable site as well, but there's a couple features that we've on our development site that we're about to roll out that we haven't done, and we'll be doing so shortly. Okay, so why don't we go ahead and take a look at one of the slices. One of the things we've been working on is ExoGenie support, and Jeannie mentioned that we initially developed the system to work with InstaGenie, and we've been over the last since the last GEC, we've been working on support for ExoGenie. And so here's an ExoGenie slice that's actually been instrumentized. And you can see here that the look and feel of the Genie Desktop, for those of you that used it yesterday, is very similar to the experience that you had using InstaGenie. You can click on nodes in the topological view here, and then you can select which graphs you would like to see. In this case, we've selected a couple graphs that we would like to see from the ExoGenie nodes. And it has actually already instrumentized them, added the software on there to collect the data, and is showing you a sort of a live view here, updated every 5 seconds, of the traffic that's going on each of those particular nodes. So like the InstaGenie case, you can mouse over these particular graphs, and you can see this is telling you one of the nodes here called MP-1, and it's being updated every 5 seconds. You see the in and out traffic going through it. I should tell you one other thing here about the ExoGenie implementation here. If you actually try to go ahead and create an ExoGenie slice, when we did it with InstaGenie, and if you're in the tutorial, you had to check a box that says use the GEMINI extensions. In the case of ExoGenie, we don't yet have that box to check. And so the way we actually do that is an unfortunate way of doing it, but we actually name all the nodes in a particular format. And by doing that, we know that you're meant to have checked the box. So the way you do that is when you're creating it, you actually name your nodes MP-something if it's a measurement point node or regular experimenter node. And if you're going to create the global node, it needs to be named GN-, some name. So they start out with MP- or GN-. And in that case, you will automatically get the GEMINI extensions and the GEMINI features when you create your ExoGenie topology. Otherwise, it works very much similar. You go to FLAC, you draw your topology, you simply have to name these things with those things, then you hit submit, and it will create an ExoGenie topology for you. It will work just like InstaGenie once you get into the Genie Desktop, and you can actually see all your data as well. All right, so that's another sort of, although it seems like a small change or very similar to InstaGenie, it actually took a lot of work to get all those features working with ExoGenie. All right, so another feature that we'd like to sort of show you is we've modified the interface a little bit, and we're starting to come out with some support for what we call modules. And can you take us to one of your slices that currently is using sort of a module support? All right, so the idea behind the Genie Desktop is that we wanted a standard theme for how you interact, or an interface, an abstraction for interacting with data. And the interface we came up with is you see your topology in one window, and you can select nodes, and then you apply an operation to them. For example, I would like to see the TCP/IP traffic for any one of these particular nodes. And then that would pop up in a different window, for example. And we've created all the windows to do these, and we've allowed you to see TCP graphs and IP graphs and ICMP graphs, and we've been enhancing that over time. But it would be nice to be able to come along and add your own sort of traffic that you'd like to see, or other sorts of things. And we'd like you to be able to leverage the windowing system and the graphing techniques that we have there. So what Wesley's been working on more recently is he actually wrote a new module, which we plugged into the Genie Desktop. And this is basically a windowing system, and it's written in HTML5 and JavaScript and other sorts of languages like that, much like you'd write any other type of browser window mechanism. And what this windowing mechanism here is doing is it is able to go off and find our data and pull it in and graph it in a new way. Okay, so he's gone off and used, I believe it's the Dojo graphing packages. And this graphing package, unlike our previous graphing packages, allows you to actually sort of mouse over the nodes to find out exactly what the data values were. So if he goes across the nodes here, you can see the data values. So it's a little bit more complicated, a little bit more informational view of your data. It also allows you to zoom in and scale the size of the chart, so it can change the number of data points that are shown. You can also move back and forth in terms of time by changing the offset here. He also has the ability here to change in this window which graphs are being shown. So he can quickly go up there and check and say, I'd like to select the TCP graphs or the IP graphs and those sorts of things. These graphs, like the other graphs, are being updated every 5 seconds, so you're seeing these live as well. All right, what's sort of interesting about this is not so much that he wrote the windowing, the window here to graph all that, and that, although that's a nicer feature, the interesting thing is that it's actually tied into the whole windowing system. So if he actually starts clicking on nodes and links over here, these actually send messages to the module that's controlling this window here to identify that, oh, they've changed which node they want to see in their topology. And you can see here the graphs suddenly changed, so now we're seeing the CPU graphs for VM1. If you click for VM2, we'd suddenly change to the graphs that you would see here for VM2. So it's completely tied into the windowing system. And as a result, you know, if you would like to write your own module that you plug into the Genie Desktop, we have mechanisms now that can do some of that. In addition to that, you can even click on things like links. And if you click on a link, it would suddenly bring up the graphs associated with that particular link. And again, all of that is based on messaging that's going on back and forth between the windowing system here. All right, so those are some of the new features. There's lots of other features that we have. They're in the tutorial that we gave yesterday. And so let me just quickly stop and ask if there are any questions. Otherwise, we'll go on to Ezra. Yes?
Can you set any types of selectors for warning notification?
Warning notification?
Threshold for the initial key?
Oh, so I don't believe you built that into the system here, but presumably you could.
Yes.
All right, so no, he hasn't done that here, but that's something you could do. But the idea was to make it extensible. So if you'd like something like that, you could add that. Good question. Yeah.
Possibility of exporting data as CSV?
So the module here is sort of is written in a way that it has to know where to get the data. So it's not, we're not sending it data. Okay, the module is responsible for getting its own data. What the module is doing, though, is it's in the context of a windowing system, so that if you start applying operations here, your windowing system's told, okay, they clicked on these buttons over here, you probably want to adjust your view. So if you wanted to adjust, if your module wanted to export it as CSV,
I guess
you could do that.
I was just looking at the graph and thinking I'd like to have the numbers in Excel. Do I need to go get them myself or can I save them?
You can, in this case right now, you'd have to write a module to do that. What Ezra's about to present, he may actually, I don't know if you have that feature in any of the,
I mean, the way we export it is to, a bunch of JSON files that are sent to the archive. So that's always an option.
Mhm.
If you archive the data and then you go into iROD and look at the raw data. The other thing is we have some standard interfaces that allow you to get to the active measurements, for instance, really easily. Just by doing a web request to the service that's running within the slice, and you just pull all the time series data out that way. That's something that we would like to export through the interface a little more, right? Yeah, so you could, like you said, you just have like a link, export to CSV or, any other format that you're interested in. You'll just get a download link to the file. That should be pretty easy to add.
yeah, I forgot to mention, there is actually, and we didn't show that the other day, there is a feature to take the data and all your data and export it to iRODS, which is an archival service. And in the case there, you're saving it as JSONs. I believe we save it as RRD files. Okay. Okay, any other questions? All right, so turn it over to Ezra.
Oh, it's really tiny. I can. Well, I think I can work with that. I'm going to be a little ambitious and see if I can drive this and talk at the same time. But what I wanted to show you is a little bit of the active measurements that we've provided within the Gemini sort of I&M toolkit. And I will just go ahead and start by well, I'm already logged in here. This is sort of my slice view on the Genie Desktop. You can see my slices here. I have one instrumentized called GEC17 Gemini, so I can just directly click on that, get right into the desktop, as long as my wireless works. Yep, there we go. So one way that we are collecting measurements is, in particular the active measurements, is through a system that involves a measurement store that runs on the global node, which you can see identified here, and a bunch of measurement collectors that we call blip that run on all of the experiment nodes. In this case, I have two, node 0 and node 1. And Jeanne mentioned these components. I won't go into any more details except to say that those components are automatically installed when you instrumentize the slice with Gemini, and that you can access their configuration and the data that they produce through this active measurement configuration page. So to get to that, you would click on the launcher icon, go to the Gemini GN option here, which brings up a little menu for the global node. GN stands for global node. And then you can open this page called psconfig, which basically stands for periscope config. And let's open that. And this takes you to a separate page where we can go ahead and start looking at some of the blip configuration and the active measurements that it supports. So you saw when the page initially loaded, you got this pulling configuration from Unis display, and that goes out to our central configuration service, pulls all the information about which services are running in the slice, and displays them here. You can go ahead and take a look at managing these services. So you go ahead and click this and load nodes, and you'll see that you have, in this case, 2 blip instances running on node 0 and node 1 respectively, and then you have the measurement store, and you can go ahead and enable, disable these globally if you'd like as well, if they're causing any disturbances in your experiment or whatnot. So that's one option. And then to actually go ahead and look at what type of active measurements you can configure, you go to this link on the side, Schedule Blip Test. And what you would go ahead and do is, from this drop-down menu, select a particular node that you're interested in configuring. So for instance, here I'd click node 0, and you'll get a list of some of the active measurements, in this case that I've already have configured. And you can see here on the bottom what we have available currently is the ability to add active measurements such as throughput testing. So if you're interested in looking at the performance between one node and another in your experiment slice, or even a host that's outside of your slice, so you have the ability to add basically any IP or host name here, and it will go ahead and fire off. In this case, we have iPerf enabled as sort of the default option, and we are, well, sorry, the screen is a little cut off. I'm not seeing that on my side. But you would see, this dialog come up. You'd be able to add a new test, new T-put test. You can specify how frequently that test runs. So you could do it, once every minute. Well, that's a little short for a throughput test. So once every 60 seconds, which is basically 1 minute. Okay. It's a challenge to try to drive and talk at the same time here. All right, so yeah, we could do, let's see. All right, let's do every hour, every 60 minutes. We can run a 30-second test. It'll be iPerf. You can have the option of choosing TCP or UDP, and you can do auto tuning, for instance, or you can specify the window size you'd like the test to use explicitly. And then we can just enter a target host. Let's just say anything that's running an iPerf server will be able to query, and I have a host that's already configured, and then you can just go ahead and add this. Oh, and there's an error for some reason. Well, that didn't show up earlier, but it would basically drop down in this menu here. And good thing I already have some configured, but you would be able to basically see it show up in the list. You would be able to go to modify and see all the options that you had just entered. And in this case, I had a number of parameters specified for this already running test. What happens then is for each of the tests that you configure, you have a number of event types that are generated for the active measurements. And the event types are really the metrics that particular active measurement will produce. So in the case of a ping test, you would have things like time to live or round trip time. In a bandwidth test or a throughput test, you would have something like bandwidths. And then you have this drop-down menu that lets you select the particular event type, and then you can go ahead and graph that information, whatever's collected on that particular measurement. So here you would have a graph of a throughput test. This one I think is running every minute, if I recall correctly, or maybe every 30 seconds. So you can basically here see all of the different tests that have been run on the intervals, see what their values are, and you have the option of selecting sort of a historical data set for anywhere from 2 minutes to 24 hours. We like to make that more of a sliding scale so you can get more archival data and specify specific ranges. But this is useful, if you're running something over a day or under, you can get some data about these active measurements and display them. And we basically have the same option here for this ping test. So this allows you to do basically ICMP traffic between nodes. And in this case, you actually get a drop down of all the different nodes that are in your slice topology, so you can add those easily by just adding them to the test. Again, you can specify the interval between tests and some of the ping specific options, like the size of the packets you'd like to send to the target host and so forth. So I have some here already set. So in this case, I have one going to that same host I did throughput testing to, this host on the Internet 2 backbone, and it's basically doing a 1 second ICMP test to that host, and we can look at the round trip time to that. And you can see that it's giving us some nice up and down values. And that's because we have a throughput test happening from that node at the same time. So you basically have periods of very low latency, and then when the throughput test happens, you can see this nice jump in round trip time. So kind of shows you the dangers of running multiple tests at the same time. But that's also good for doing experimental analysis. So you can do these ICMP tests while you're running something in your experiment and see the effects of other metrics that you're collecting. And then I guess the other thing to mention is that these graphs come up however many you want to display. They just show up in a new window and they update in real time, so you can get a sense of what's happening for multiple metrics as you're running them. So the other thing I wanted to demonstrate real quick is this idea of a netlogger probe. And on node 1, I have a couple of these tested. Now, netlogger is a software toolkit that provides sort of a set of standard best practices for doing log reporting from any type of instrumented application that you're interested in collecting data for. So you basically have a bunch of libraries written in C, Python, I think maybe even some Java libraries that allow you to link against a running application and basically record events that are happening. So if you're trying to instrument a read or write system call, for instance, you can see how long it takes to do that particular system call and write that information out to a log file. And what we've done here is so if you have an experiment that you're running and you have a particular application you're interested in instrumenting in that way, you can write that to a temporary space on the node and then configure this probe that allows Blip to go out and look at the file that's being collected on the node, parse it, and then export all the data from that log file to the measurement store in the same format that we're collecting all of our other active measurements in. So I have a couple examples here. One is just using a netlogger CPU probe that basically just collects CPU information from the system and exports it to a log file. And then you basically graph that data. I'll show an example of how these log files look, what these log files look like. The other one is just basically an example that I have in the tutorial page that collects a number of random numbers and exports it to a file, or generates them dynamically, but it runs, and then you can go ahead and see what that looks like, in a graph. So basically anything you want to instrumentize or instrument in terms of an application, you can do so, dump the data to a file, and then use this interface to basically parse it and export it to the measurement store in a normalized format. And in this example, you can see that I am just calling this random. I'm looking at the file every 5 seconds. That file in question is /temp/random on node 1, and I'm reporting every 10 new items that I'm seeing in that file to the measurement store every 10 times, basically. So the way that actually looks, I don't know if this is visible or not. Kind of hard to see. I'm sorry, my screen is widescreen and this is not stretching for me. But let me move this over. Increase the size. Look at that. So if I go to that particular node in question, this is running at Kentucky and on a VM. And what I did is I have this netlogger_test.py. There's an example of what this would actually look like. So there's basically a simple Python script. You can use the netlogger tools and software. In this case, the Python library that's already installed on all the nodes that are instrumentized. It's just a simple example of how you would take an application, import the netlogger modules, and then set up some type of event type In this case, I just call it my namespace, and I'm getting basically random values in a while loop and reporting them to a file. So I would just run this like netlogger test temp to, and so yeah, that's what I ran. And basically that's just going to dump a bunch of log messages to that file. And if I take a look at what that looks like, you would see log messages that look like this. So basically the event type, a timestamp value, and then the actual value of whatever you're interested in collecting. And like I said, that could be anything that you are interested in looking at was in your application. You can dump to this file and then configure the active measurement to take a look at it, export it to the measurement store, and then you have it, save it to the archive. And I think that's pretty much all I wanted to cover for what we have. One of the things that we're trying to do is instead of having separate views of the data, basically it's kind of nice to have the event types drop down here, see the graph of what you're interested in, but using the new module system that Jim just demonstrated, we'd like to be able to tie that in more closely so you can get that same information directly from the same interface here. So that's on our agenda. So if you look at the current stable edition of Gemini Graphs, we have some of the blip event types already listed here. So you can get information on if that node is doing bandwidth testing and ICMP testing, you can get it from the desktop currently, but the charts are not as nice as they could be. So we're hoping to really incorporate that better into they're sort of summarized information without the ability to scale and so forth. So we definitely like to incorporate all the active measurements that we're doing in that separate GUI into the desktop. So that's sort of the future directions. So at this point, I guess I'll stop and ask if there are any questions about configuring active measurements or getting access to the data, displaying it. I'd be happy to answer that. And I guess I could also mention that there is a quick wiki page on doing what I just described. If you're interested in trying it in your own slice, you can go to the link, and there are instructions on how to go ahead and try that within your own experimental setup. Yep.
Are there any OS restrictions on what types of nodes can support eventually?
At this point, we've really focused on sort of the default images that are provided in InstaGenie and ExaGenie racks. I know in InstaGenie we have Fedora 15 supported, but we also have just recently added the Ubuntu support. So they should work on both Fedora and Ubuntu images that are available. In ExaGenie, we have them working on the CentOS images that they have available there.
Is it all user space stuff, or is it
This is all user space stuff. So yeah,
all
right. Yeah, as long as you get all the dependencies set up and you can see some RPM repos, you can pull all the stuff and get things installed pretty straightforward. Yeah. All right, I guess with that, we'll hand it over to the GIMI folks. Thanks.